Welcome to the Cambridge Tech Podcast, talking all things technology from the heart of the UK's tech capital. Here are your hosts, Faye Holland and James Parton.
I'm Faye, and I've got just a couple of pieces of news for you this week before we head into the episode. First of all, Cambridge-based materials innovation company Sampler continues to make headlines as it heralds a major commercial advance, with Bunzl UK and Ireland adding Huhtamäki's Taste hot food boxes with Morrow coating to its comprehensive range of food service packaging. Bunzl UK and Ireland is a leading supplier in the food service sector, providing a significant platform for the introduction of Sampler's Morrow coating to the industry. The taste boxes are available now across Bunzl's extensive network of operating companies, delivering to national restaurant chains, transport hubs, hotels, contract caterers and stadiums across the UK and Ireland. So anyone interested in learning more about Sampler's amazing journey can head over to their feeds, or they can tune into episode 142 with Sampler's CEO Alexandra French. And we also have congratulations to Alan Boswell Group, which has major offices in Cambridge. They have just been named Insurance Broker of the Year at the British Insurance Awards 2025, hosted at the Royal Albert Hall. The award recognises outstanding customer service, client retention and excellence across the UK insurance industry. The award follows the group's continued growth and success, with the recent acquisition of 3 brokers further bolstering its presence across England. So congratulations to Alan Boswell Group. And now to our conversation for this week's episode with Christoph Schnedermann, founder and CEO of Illumion. Hi, Christoph. It's great to have you with us today. Thanks for joining us.
Thank you for having me.
Let's start with your academic path, actually, because I think that's quite an interesting discussion point. So you went from Jena to Oxford to Harvard and then finally here to Cambridge. How did those different places and environments differ? And did you find that it's shaped what you've actually built now as a business?
Yeah, I think it always does, right? You spend different amounts of times in different communities, especially with different places like Germany, the UK, the US is a very different place as well to do anything really, as far as I'm concerned, even though I was only in Boston, which is, as far as I'm concerned, the most European place in the US. I think mostly what shaped me was the people that you meet, right? You get different ideas, different perspectives to go through. In Germany, the town I'm from, Jena, is very much optics focused. It's a little university town, so a bit similar to Oxford and Cambridge, obviously not that world-renowned. And then Oxford, where I did my PhD, my undergrad in chemistry, in fact. You know, you learn a lot about people that you see at these places that motivate you doing different things. And I was always going to be an academic originally, right? So me being on this podcast is quite interesting. And that is part due to the environment and just what you see, what motivates you, what gets you there.
And so you have ended up building this deep tech startup. Do you think that there was anything from those connections that you made that you can pinpoint and say it was that bit that made me think, I should really go in a certain direction?
I think it's a little bit different probably for me than for most, because as I said before, because I wanted to always be an academic, I was always very much driven by doing something different. You know, you read the academic literature, you learn a lot about what people have tried. Your job as an academic is to figure out what have people not tried and how could that add value, which in a way is very similar to your entrepreneurial mindset, but the commercial focus is very much not there. So, you know, I think in terms of my general path, being an optics town, that kind of set the precedent of always being interested in how light interacts with different things. So that was always my core focus. And, you know, people often kind of define themselves by one technique or one thing that they're really good at. And I think for me, it's basically just shining light on things and seeing what wonderful, amazing things it does. And that kind of led to Illumion in the end.
Yeah, that's really interesting. And, you know, we have a lot of Cambridge University spin-outs onto the podcast, and, you know, a good proportion of our audience are budding entrepreneurs, right? That are, you know, currently studying or doing their research. So I'd be really interested to understand, especially as you said in, you know, your answer to Faye, that your intention was always to be an academic. As you were doing your research, what was that tipping point where you kind of switched from the pursuit of the knowledge to, oh, actually, this could be a commercial opportunity? And where was that light bulb moment that actually this had that potential to spin out into a company?
Yeah, I think ultimately it's like all the other stuff that you see here. Mostly it's a conversation over lunch or in the pub, and it was basically the same here, to be very honest with you. So, you know, we started working on the science that led to Illumion in 2018 when I just joined back in Cambridge in Professor Akshay Rao's lab and worked together with Professor Dame Claire. Those are the academic co-founders, together with Alice Merriweather, who was my PhD student at that time. And, you know, that was all just, can we actually do this? Is this even a possibility? And we can talk about that, what we do a little bit later on. But the moment we've had something, you do the usual academic thing. You collect your results, you do your due diligence, you write a paper, you publish it. And usually at that point, an academic goes and moves on to a next interesting thing to do. It's very difficult these days to really have long, sustained academic careers with all the noise that is out there. So you get very little feedback from the scientific community. And at that point, I would have been in academia for 12 years. And that was basically the impression that I had. But with this particular publication, we actually got some real interest. People asking us, oh, can we do this in our lab? Can you help us understand this system and this material? And could we collaborate? And it was much more significant than in any of the other branches of science that I've been working on before. And I think at that point we were kind of like, actually, you know, we might be on to something here. Should we do something? And I was literally a conversation over lunch where we decided we should do it.
Okay, so once you'd kind of finished lunch and you'd made that decision, but what kind of support have you had from the university in going on that spin-out journey? And has anything surprised you through that process?
Yeah, I mean, the university itself has amazing programs that help spin out companies. Now, we probably missed all of them. So we've kind of done it in our own unconventional way, which is not a bad thing for a startup, I would say. But the university, because of these other systems, all these ecosystems that is there, has been incredibly supportive. You know, we've obviously with all these things, you work with the tech transfer team together to identify whether this is a commercial opportunity or whether it's that from the get-go because there's patent protection somewhere else that you can't get around and all of these kind of things. So they've been really supportive, been really helping us to kind of clear the way and actually get to the starting point of founding the company. And then, again, in their credit, you know, at the beginning, a startup has to just do what a startup has to do, so they left us alone, which is very important as well to understand and appreciate. So yeah, I think that's kind of how the university helped us directly, indirectly, as I mentioned, because we're sitting in a Maxwell Center, which is a great place for starting up a company and a few other companies around. That kind of creates an environment where you can talk to other founders. You can share your pain points, and everybody really has the same pain points. Oh, this investor isn't playing ball. These are the problems that I have with my supply chain and so forth. So that was really, really helpful for us to kind of just come to grips with the fact that, you know, startup life is a bit more difficult than we thought it is, but it's doable.
And we'll definitely come on to that.
So let's talk, Christoph, a little bit now about Illumion itself. So you've taken your lab work on single particle imaging, turned it into a company. And if I read the narrative, it says that your charge photometry platform offers real-time single particle analysis of ion movement inside batteries. What does that actually mean for those that are less familiar with the topic? You know, what are you measuring? Why is it important?
Yeah, so a battery like the ones that you have on your laptop and your phone, they're actually quite complicated things. And if you break it down, they, at the core of it, have inorganic materials mostly that take ions, in our case, lithium ions, into the material, out of the material to do the energy storage process. Now, for the most part, it takes about 10 years to develop new materials before you can even scale them up and consider putting them into a consumer application. And that's been true for all the commercialized materials so far. And that's a really, really long time, especially if we want to try to hit net zero by 2030 or whichever guideline the government is putting out next. So at the end of the day, you have to figure out how can you actually develop materials faster. And one of the most natural things we as humans know how to do is just to look at things, how they change, and iterate based on that. But that is usually very commonplace in the life science. You use microscopy to look at how cells do their thing. It doesn't exist in the battery space. So essentially that's what we wanted to do. We wanted to basically be able to provide a lens into the inner workings of a battery at the R&D stage where there is a critical gap, so that you can much early on in the process understand why a battery material that you're developing may not be working, or may be working particularly well in fact as well. And that should then help companies, researchers, and generally everybody who is looking to develop new batteries to speed things up. So that's kind of what we do. So at the core of it, it's shining light on the battery and checking how the light interacts with the material, and from that you can infer what's gone wrong or what has gone right.
You mentioned the R&D stage of the battery. Is there kind of an in-life health of the battery application there as well, or is it more focused at the kind of R&D stage?
That brings it to the battery value chain quite nicely, right? So you basically have your R&D, and then you have your manufacturing and scale up and further downstream applications. There's a lot of companies and a lot of really exciting work going into the manufacturing and fantastic processes being developed there. It's a very crowded space. There's very little actually being done to cater to the research advancements of it. Most of the time it's tools, characterization techniques that have been used in other fields before that have been kind of coerced to do batteries. What we thought is missing is a dedicated tool that allows you to speed these things up. So our current market focus is really just the battery R&D. And then from that point, we'll essentially try to see how we can branch out into the manufacturing, into potentially battery recycling, where we see quite interesting applications. And then in fact, all simultaneous, similar electrochemical systems as well. Think of it as catalysis or various other spaces like that.
Because I guess it's important that as an early stage company, you really focus on something rather than try to do everything at the same time, right?
You just don't have the resources. You have to go laser focused after one thing and get it right.
Yeah. So maybe kind of indulge us in terms of explaining what the kind of battery R&D market looks like in terms of the value of it, and what kind of reaction have you had from the investor community in terms of what you're doing?
Yeah. So most of the time, as I said, the investor community will be looking mostly at how can you use it in manufacturing. That's where your high value opportunities sit, and that is a very perfectly good rationale. There's, however, a really quite large market opportunity for the R&D sector, because even if you just consider academics and universities out there that are working on new battery materials, you would be easily looking at thousands of them, right? So the market opportunity to sell instrumentation into that sector is actually really quite large. And especially, because what's really nice about the R&D sector is that people actually want to understand how to make things better. So there's a good amount of open knowledge sharing as well. So it kind of connects back to our core roots as academic founders, which is us trying to give something back to the community, but really also understanding that because it's often seen as a little brother to manufacturing in the battery value chain, not much is done for the R&D space. So it's a good value opportunity for us to very quickly make an impact.
Interesting. So your actual target customers then are going to be academics. They are going to be the battery technology companies at the development stage of the next gen of batteries.
Precisely, and especially with a drive towards vertical integration in companies, all of these R&D efforts are all done in-house. You get massive R&D teams from the big companies, which are doing really amazing work, and that's what we're trying to get into. And through that, you start essentially perforating through the battery value chain.
And are they fast adopters of new technology, or is it quite a complex sales process?
It depends. We've been able to sell a unit in as quickly as 5 months. We've also sold a unit which took 2 years. So it is very difficult to predict process at the beginning, because if you're starting with a new disruptive quote-unquote technology, there's a lot you have to do on thought leadership to be able to educate your users, to be able to make sure they understand the value proposition that you bring to the table without them being the experts who have been looking like us at this for the last 7 years. So it really becomes a slightly longer sales process, especially because the battery funding that's available for these kind of things is quite dependent on national strategies. And more recent geopolitical events have made that a little bit more difficult to predict, unfortunately.
The sales cycle is obviously very varied, but therefore it also means that how you can quantify the impacts of what you're doing to those companies is going to be very varied as well. Is that true? Or do you start to see the same, once you're in there, do you see the impact so quickly for them? I appreciate you may not be able to share all of that, but is there anything you can share?
Yeah, no, I mean, it comes down to essentially if you offer a tool that can look at various different things, and our kind of charge photometry technology, which our product Illumion 1 is providing our customers with, can look at your anodes and your cathodes at different material systems, but each material system will have a different question attached to it on how to optimize it, right? So that fundamentally poses a challenge in quantifying for each use case what it is, because you would have to do each use case, but if you had the use case, there wouldn't be a company interested in doing it, right? Effectively. So what you end up doing is you're trying to really nail down the most critical use cases that are out there. So we see in the market, especially in the European market, a very strong preference for new anode materials that are not based on graphite. There's some very innovative companies here in Cambridge that are working on this, but also generally throughout Europe, there's a lot of drive to kind of wean off of graphite and do different chemistries, and those tend to cluster together, so we can provide a solution for that. Similarly, in different regions, it becomes more region-specific what people are interested in, so we try to kind of target it. So, to give you, however, a slightly more general example of how it can be worked, one of the key questions in batteries is always degradation. Can I have a battery not degrade over 10 years or maybe over 20 years. So, in the R&D process, the way you would usually do is you make 10, 20, 30 cells of the same material, same composition, and you basically charge and discharge them a different amount of time. And then you break them up, you look at them with other tools to figure out why things have degraded. In our case, we can use one cell, track the same amount of particles throughout that entire degradation process, and therefore speed that process up X times, depending on how many cells you would run. So that's an easily 10, 20-fold improvement on the throughput that you can do. So that's just one example where charge photometry is particularly powerful and a little bit more material agnostic to the specific question.
Super interesting.
So I wanted to move on and talk about Cambridge and the kind of battery cluster in Cambridge. You mentioned Claire earlier. So you actually share a co-founder with Nyobolt, which I think is really interesting, which is another very well-known and growing, scaling battery tech company in Cambridge. So tell us what it's like to be a battery tech company in Cambridge. Is it a collaborative community? How's recruitment? Is it super competitive between all the different companies? Is Cambridge going to be the place that you stay to scale the business?
I think so. So, Illumion is a little bit different because we are not a company that is making materials that go into the battery. We enable those companies. So for us, it's a brilliant place because there's so many companies spinning out of Cambridge that make materials. There's, Nyobolt, we've already talked about, Mekion, who's also who are doing great work in the kind of fast charging space. Taizan and Molion are very good companies that are all spinning out through different university processes. And, the fact that I can name them here means that we're all connected already, right? So because it's such a driven community, such an innovative, focused group of people in Cambridge, you just meet everybody very quickly. But it's Cambridge Enterprise hosting meetings that you get together networking meetings, or whether it's Foresight, one of our investors, putting on essentially networking sessions. You basically, if you start a company in that space, in the battery space, it takes you probably about a month before you know most of the people who you really need to know. And that's great about it. So you can very quickly scale. Now that has implications for the recruitment process, and there are lots of recruiters working in the Cambridge area, which makes this not necessarily easier. But for us, it's actually been quite good. Most of our early stage hires we get through the network, so not necessarily for recruiters, but because it's such a well-known space and because the profile of an early employee is very well understood in Cambridge, hiring can be really fast as well. So I suspect it is a very good place to scale true battery companies. Certainly for us, it's a very good place to scale up because we are really plugged into the next generation trends.
And the team size is around 10 people at the moment?
So currently we are 10. We just finished hiring.
And you've just added some experienced people for the commercial side of things.
Yeah, exactly. So we started off, we had our first hire, I think, in January 2023. Then we were about 4 or 5 people for the best part of the initial product development. And then through our seed round that we concluded last September, November, we basically doubled the team. So we put a lot more effort onto the front of the business, hired business development people, chief of staff to really drive the front end of the business in order to get that commercial outreach.
So I think that community of interest approach that you've just talked about, we hear all the time on the podcast, as you can well imagine, but it's such an asset for everyone here that you can learn and share and develop, I guess, in a quicker way than if you were just doing it on your own. Now, I'm going to go back right at the start of the podcast. You talked about how Cambridge University had kind of left you alone and you'd done it a slightly different way, you know, whereas some of the others may have gone through some of the programs initially. So you've followed your own path, but there was an interview you did with Cambridge Angels, another one of your funders, where you said that at one point we came close to shutting down operations because it was nearly impossible at times to run the business. And you've come from an academic background. So what were those challenges and how did you get over them?
Yeah, so I think it is important to appreciate that startup life, especially managing a company, is not always roses, right? And I think everybody who would have been sitting here will have told you similar stories. It is ultimately a very, very hard job, and you can only do it if you're tenacious and you believe in the idea that you have. But actually, what I think is much more important is that you have a team that you can lean on in these situations. So, you know, last year was very, very hard to raise. You can ask anybody. It was very difficult to get money. No matter how good your idea is, it doesn't matter if the market isn't there, you can't raise, right? So as a result, funding cycles have increased from the usual 6 to 9 months to 12 months plus, and that makes it very difficult for an early stage startup like ourselves to plan. So I think the biggest challenge and also the biggest revelation at the end I've had was that, you know, you gotta trust your team to keep the business running while you are fully committed to getting the funding for your team and for your business. So, you know, that was the challenge. It is hard to raise, especially if you have at the end a forecast and you know that you will be running out of money. And if you're in your private life, you have an overdraft. If you're in a business, you don't have an overdraft. That's game over and people lose their jobs. And that's something that, you know, I wanted to avoid at all costs. And luckily enough, we managed. But, you know, the kind of revelation here really is value your team, ultimately.
That's great.
I mean, that's been a really, really interesting conversation, I think. And I wanted to kind of just wrap things up by just asking you about, you know, what does the road ahead look like? So as you look, you know, towards the end of this year and into 2026, what are the kind of key milestones approaching that you guys are looking to hit? And, you know, what does the product development roadmap look like?
Yeah, absolutely. So, I mean, as I said, we've basically just completed hiring and doubling up our team. So we're now fully equipped to basically charge ahead with the roadmap that we've laid out. So essentially, we are in a position already where we're revenue generating, which is probably a bit unusual for a seed company, especially a deep tech seed company. So for us, it's effectively a two-pronged approach. Number one, we are continuously innovating on our ability to provide these single particle insights to the battery communities, looking into different use cases, different cell types. So, for example, solid state batteries and so forth, and trying to essentially provide the kind of best possible offering to accelerate that R&D piece that we've talked about. But at the same time, we're now manufacturing. We do everything in-house. We have to scale that up. We're scaling that up with cost down manufacturing and all of these kind of different aspects that you have to consider the moment you're actually bringing a product to market. So, you know, the next milestones for us is to increase our sales, get out there, sign up with distributors that essentially help us to get international coverage. As I mentioned, we've sold 4 instruments already internationally, and that was a steep learning curve to understand how you actually even just do that. It's not necessarily straightforward, it turns out, but you learn along the way, and that's basically for us the goal. So for now, the first step that we're looking at is get to a classic break-even scenario, so that we essentially have the choice to decide whether we need to raise more or not. And off the back of that, we can then go after specific high growth value opportunities that might be in the recycling sector, that might be in the manufacturing sector, or that might be in a different electrochemical materials or energy materials space.
So I just wanted to go back on something you mentioned there. So you're actually manufacturing the instruments yourself as well as the design piece. Okay, that's really interesting. Are you doing that locally, or you?
Yeah, so that's all done in the Maxwell Center now, where we have our offices.
As you kind of scale the business, then a kind of production facility is going to have to be something that you think about.
Exactly. So once we hit a certain sales threshold, a number of sales per year threshold, we'll have to look into premises outside of the Maxwell Center. Again, Cambridge is a perfect place for that, especially Science Park and so on has lots of possible opportunities to exactly do that. So that's where we are.
And you feel like you'll maintain that in-housing of manufacturing because it gives you kind of end-to-end control of supply chains and all that kind of stuff?
Yeah, that's basically why I've decided to go down that route for now. It's really important that you're not bogged down by a project partner who doesn't pull their weight and that you can't control. So that's really why we've gone the slightly more internally labor-intensive route of manufacturing everything in-house. Also, it gives us the agility to very, very quickly respond to different demands. So if we need to push out a new product with different requirements, we can do that very quickly. Whereas if you have that outsourced, you really only can do that if there is a very specific requirements brief that exists. And in an early stage disruptive technology, you just cannot have that.
You're in a great location as well, because actually we have now a buoyant manufacturing community across Cambridgeshire. So when you look just outside of Cambridgeshire city, then you go to Huntingdonshire, up to Peterborough, those kinds of areas. We've actually got a lot of expertise in manufacturing now. So you've got the ability of staying more local than I guess many would think. But Christoph, thank you so much for your time today. It's been really good to catch up with you. And, like you said, you've got some great funders and backers behind you. So we wish you all the best and let us know how you get on.
Thank you so much for having me.
Today's show was produced by Joe Donaghy of Cambridge TV and supported by our media partner Business Weekly. The Cambridge Tech Podcast is available on all major podcast platforms and on cambridgetechpodcast.com. If you've enjoyed this podcast, please give it a 5-star review. It'll really help others discover the show.